here in email. So first, let me say a big thank you to email company that we can have meetup here. And I'm glad that you came to our 6 Kotlin meetup, first meetup in this year. And it is big honor for me welcome on our Czech Kotlin meetup Mr. Hadi Hariri for second time. And his talk will be about functional programming. After this talk, there will be some space for question and answers. So you can ask to Hadi about something about Kotlin. So we can start.
Thank you. Thank you, and I want to say thank you for having organized this on short notice. I really didn't give him much time. I just said, hey, I'm coming. You want to do something? He's like, okay. And thank you for everyone for showing up. So sorry, I've got to record my screen here. Start recording. There you go. Okay. This is the moment where I'm like, I'm recording my screen. Is there something I shouldn't be recording? That's public. That's okay. So yeah, we can cut it out. Okay. Anyway, so welcome. That way.
Yeah.
Okay. So I have to lean over. No.
No, you don't need to.
I don't. Okay. So welcome to this talk on functional programming. How many of you are Kotlin developers? That's only like half of you. What are the rest of you? Java? Huh?
Yeah, Java developers.
Java developer. So you don't do Kotlin? So what was it? The wraps that you're here for? Okay. Well, thank you for coming for the wrap. I mean for the Kotlin. So how many of you here are familiar with Kotlin syntax? Okay, so maybe a few of the kind of more advanced, quote unquote, advanced things I will run through so that we're all on the same page. But anyway, what I'm going to do is give you a little bit of a talk around functional programming. Functional programming you can interpret as anything you want. Depending on who you ask, they're going to tell you different things. And if you ask a .NET group of developers what is functional programming, they'll say to you F#. If you ask a Java group of people, they'll say to you Scala. If you ask Haskell developers, they'll just be like Haskell and nothing else is functional. So it really depends. It's kind of like the consultant, right? You know, a consultant, when you ask a consultant how do you solve a problem, they're like, it depends. So with functional programming, it kind of like depends on how you look at it. I kind of like stick to the definition of Eric Meyer, if you're not familiar with Eric Meyer, he was the guy that introduced functional programming to C#. And back then he called it LINQ, or Language Integrated Query, and everyone thought that what he's introducing really is how to do SQL mapping, but it was actually functional programming. And he says that any language that kind of allows you to treat functions as first-class citizens, as primitive building blocks, could be considered functional programming language. Now, to all practical effects, Kotlin is a functional programming language because, hey, why the hell not? If it wasn't, I wouldn't be giving this talk, or I would be doing it in Java. And in fact, when I talk about Kotlin, especially to people that are new to Kotlin, I say like, are you object-oriented developers? They're like, yeah. I'm like, well, Kotlin is an object-oriented programming language with functional constructs. If I talk to a group of functional programming developers, I say Kotlin is a functional programming language with object-oriented constructs, right? It's basically who you're targeting. Just let them hear what they want to hear, okay? So before getting into like functional programming and what it is, what we can do with Kotlin and what we can't do, etc., the bigger question is like, why the hell do we want to do functional programming anyway? So I usually kind of ask this question a lot of times when I'm trying to adopt something, like what is the benefit of it for me? And I want to start with some sample code here, which hopefully you can all see. Can you all see that, everyone? Right? So here's some sample code. Now, the left screen is exactly the same as the right screen. So, I'm sorry, I'm thinking split vertically in IntelliJ, but it's not. So, raise your hands once you figure out what that does. And meanwhile, I'm going to drink some beer. You don't have to shout it out. You don't have to tell me what it does. Just raise your hands once you've figured out what that does. So I got 2 people put up their hands. Anyone else? Yeah? No, don't. I said don't tell me what it does. Right? I don't want to know. It does something. That's the important thing, right? We know how to name things, right? It does something. Okay. So now I'm going to show you some other code, and raise your hands when you know what it does. Right? So the hands are going up way faster there, right? And you know that this does something also. And if it's not hard to understand that despite the return type, this is actually the same thing. So it's actually performing the same kind of operation, right? It is grouping elements and then creating a list that maps the key to the value. Okay? Now, why did it take you less time to discover the second one? It was easier to read, right? It was easier to comprehend. And this is essentially one of the essences of functional programming, right? The idea that you don't mess up your code. The idea that you take functions as primitive building blocks and abstract away the implementation and use these functions and pass around these functions. Now, we're very much used to this, right? I mean, all of us have done some sort of functional programming in the past. I mean, if you take a look at this, like, you don't even need to know how group by works. You know that there's a function called group by, and you kind of intuitively understand that if a function is called group by, it's going to group by something. Okay? Map is a little bit trickier. If you're not familiar with map, you may not know what map does. But if that function was called take the list and apply another function to each element of the list and return a list, then you would know. I mean, it would be a very, very long function name, but you know what it does. But the idea here is, what is it? It's essentially just taking functions as primitive building blocks and using these to abstract away implementation details, right? You do this quite a bit. I mean, if I write a main function here, how many of you have written a for loop like this? For e in 1 to 100, and then print line e, right? Or print line e plus 10, or what have you. This is a for loop in Kotlin, right? It's going from 1 to 100. You generally don't write this anymore like this. You would do something like, for example, val numbers equals 1 to 100, and then we would do numbers for each, and then do something like, print line it plus 10. How many of you have used for each? Right? Everyone uses for each, and you don't think twice about it. And if you ever navigate to for each, what is it? Oh, look, it's just a for loop, right? All it is a for loop that just goes through each element in the list, in the collection, and then applies a function to it, right? Now, if you're not familiar that much with Kotlin syntax, just to make sure we're on the same page, let me just go over some of the syntax quickly. So this is a function in Kotlin which you can write on a single line, okay? And then you can write a function which is a high order function, which is a function that takes a function and returns a function. So I could say, for example, xy takes an int and takes another int and returns an int. So that's a higher order function, and then I can call that higher order function by passing in a function that matches that syntax. So sum, or I could just do a lambda, pass in a lambda, xy equals x plus y. And of course you can do this in multi-line in Kotlin. And of course you can also, if it's the last parameter to a function, if the last parameter to a function is another function, you can exclude it outside of the brackets and write it in multiple lines, which is kind of nice. By the way, the most interesting thing you'll learn here today is, instead of doing F, what you can do is write Alt F, and Alt F is on Mac, it is the mathematical F function, and then in IntelliJ I've mapped that to a template which prints out a lambda. Okay, so there you go. Now you're doing functional programming. I swear you can actually get away with it if you just start writing lambdas everywhere. They're like, oh, this is really functional. So all I'm doing here essentially is just using higher order functions and passing in different actions to these higher order functions. Nothing out of this world. Everyone does it. It's very simple. And yet, for some obscure, weird reason, this is kind of like a lot of times the limit where we stay. We're like, okay, I'm doing functional programming. Yes, what are you doing? I'm using a for each. Okay, I'm doing a map. I'm doing a list. I'm doing these things. And then anywhere beyond that, we kind of like shy away from, and we're like, no, this is a little bit too complicated. So I'm going to show you a little bit some of the other things that you can do here, and how you can leverage Kotlin syntax to do this. And for this, I'm going to show you different things. One of the things that I'm going to show you is a library called Arrow. I don't know if anyone's heard of it. Has anyone heard of Arrow? Anyone uses it? No, that's way too complicated to use, right? So Arrow is, yeah. Oh, sorry, I don't have internet. Yeah, never mind. Arrow has a really cool website, and it is actually Arrow is a combination of two libraries. One of them was called Functional with a K, right? Because that was actually, I think, the first library ever in Kotlin that decided to replace a C with a K, and it was really, really hip and cool then. And there was another library called Category, yes, with a K, and they decided to merge and call themselves Arrow without a K. Okay, so Arrow is basically like the merge of Functional and Category, and Category actually comes kind of like trying to bring some of the concepts that existed in Scala to Kotlin. Now what I'm going to show you is some things that are available in Arrow, and then we'll talk about some things that you can do yourself, and a lot of the things that are available in Arrow you can actually use yourself. One of the good things about Arrow is that it's extremely modular, meaning that you don't have to bring everything in. You can just use little segments of Arrow as and what you like, which is kind of like what I do. So before diving into Arrow, let's look at a simple example that we often end up with. Okay, so I'm going to create a function here which is called get HTTP request. Now we all do, anybody does HTTP requests? Yeah? Okay, nowadays well, back 6 months ago it was fashionable to call this REST, but apparently REST is the new SOAP, so you don't want to use REST either. Now it's like graph data or whatever, which is completely not comparable to REST, but never mind in this world. So let's do like a get REST request, okay? And I'm going to pass in a path that's going to take a string, for instance, and then this returns a string, which is like the contents of the REST request, right? So I say if path is not equal to empty string, which you don't write like that in Kotlin, you write is not empty, then return, for example, HTML and some contents, right? So I can say body and then whatever, okay? So I can return some HTML here, etc. Now, oh God, if only I had a good IDE. So now, else what I would do is, for example, what would I do? Like, what would you do in a scenario like this where you have an HTTP request, and if the path is not empty, you're going to return a value, which is the contents of the page. Otherwise, you're going to, what, throw an error, right? How many of you do something like this? Throw exception. Not found. No? Nobody? Okay, a couple of people. Some of you may do HTTP exception, right? Define your own exceptions. Some of you may go back to the old-fashioned way and say, you know what? I'm going to set message error equals true, and then error is actually going to be like a property that I'm going to pass in or what have you, and that's a little bit painful, which you can't even do in Kotlin. So often what we can do is create a class which is, for example, result, and then say val contents string, and then var is error string, no, not string, boolean, and then var message string. Okay? And then we've got to figure out that, okay, well, if it is valid, then I will return result with contents. And since it's not an error, I'm going to default this to false. And then I'm going to default the error message to double string. We're not very good at naming. This would be error message, but we'll just call it message to even confuse developers even more. And then otherwise, I will say, for example, return result, empty contents, true, and then not found, or something like that, right? Why is this complaining? Why is it complaining? Return string, return result. Okay, I could do something like that. Now the problem, of course, with this is what? Because again, we're not very good at naming things, so instead of calling it error message, we call it message. So now I don't know if the message is applicable when there is an error or when there is not an error. And if there's more complex variables that I'm going to pass back, that becomes painful. So another better way to do this is, for example, have a class and then have, for example, a success, which returns the contents of type string. And then it returns a class failure, which is the message of type string, right? And then these two inherit from result. And they don't need anymore each of them to define all of the properties. Result doesn't have to have any properties here. And then what I can do is return one or the other. So I can say result success, and then here result failure, right? This has to be open so that I can inherit from it. Okay? Now, the problem with making that open is that tomorrow, I'm from Spain. Why would you care if I'm from Spain? Because I don't know. But in Spain, we have this other very good saying, which is called mañana, right? Everything tomorrow, right? So I come and I say, well, mañana inherits from result, and now I don't capture the concept of mañana, right? Mañana means tomorrow. We basically delay everything until tomorrow. So what you can do is to avoid scenarios where people are basically inheriting from your code, from your class, what you can do is use what's called the sealed keyword in Kotlin, which basically closes the hierarchy, right? Meaning that if I come here, this no longer is valid because it says that it cannot access that member. The only place where I could actually define this would be in the same file. Have you used sealed? Yes? Okay. So this is good, right? It's a step in the right direction because it's providing us with a little bit more information on what it is that's going to happen in that method, okay? And why is that important? Well, let's take a look at this example over here. Let's say that I write some, I'll create a function called blah blah that is int y, right? And that returns an int, okay? Is that true or not? I mean, is that a truth or is that a false? Is that, oh, I'm going to come up with a new term. I'm going to call it true code, or is it fake code? Fake code. I like that. Fake code. Is this fake code? Okay, well, you don't like, what the hell? How do I know if that's fake code? Well, I'll say, well, to do write implementation, right? Now, is that fake code? Yes, why? Why not? What do you mean, why not?
It returns exception.
How do you know? It says blah blah. Where is it? Well, okay, yeah, because of the to do. Okay, fine. But, you know, the problem is that exactly you've proved my point, that you had to look at the implementation, yes. Right? So if I were to fold this up and I say, is this fake code or true code? What would you say? I don't know. Now, if I say divide, what would you say that is? You don't know? Well, I mean, let's assume that divide means actually divide something. So that is actually fake, right? Because there are scenarios in which x divided by y won't return an integer when y is 0. So that is what's called in mathematics a partial function. a function for which there are inputs, for which there aren't outputs, right? The opposite of a partial function is called a total function, which in mathematics is just called a function. See where I'm going? Right? Everything normally should return accurately describing what the function is doing. In our case, it doesn't, because here it's returning an integer. So how can I fix this? Well, that's a problem, right? Because here I would have to say, well, this is going to sometimes return an exception, sometimes return an integer. And this is a problem because this is lying to me. Whereas in this case, well, it is not lying to me because it's saying I'm returning a result. And sometimes that result can be success, sometimes it can be failure, but I'm always returning a result. If I had put string and throw an exception when I couldn't find the path, then it would be, again, lying to me. Now, if we are agreeing on the idea that code should be readable and comprehensible by people, and they don't need to step through it to decode, you want to make your code as accurate as the reality, right? You want to name things properly, and you want to make sure that they behave in accordance to what you are writing. And that is the idea behind this, right? Try and make things as accurate and readable as possible, or comprehensible as possible. But when I do this, what happens? Now I come here and I say, okay, well, val a equals get rest request, and I say something, and then I say, now, okay, when a, and then say is return result success, then print line contents, right? A contents. And then I do when result success is failure, then return result message. Okay? Now, what's the problem with this? Time for beer. Is there any problem? Well, yeah, if somebody adds a new type, what you should actually try and do is, that's one of the reasons that you should use conditionals as expressions, right? Because if you say, for instance, here val b equals, and now if I add a new type, it will check that it's not exhaustive. But yeah, that's one issue. But you have that issue anytime you use anything like an enum or a conditional like this. But what is the issue here? So we said, hey, you know what? Kotlin is awesome. Right? It's awesome, right? Kotlin is awesome, and it's cutting down a whole bunch of boilerplate code. And what have I gone and done? For me to return a function that is more accurate, that is more descriptive of what it is that I actually want to do, I have created a hierarchy of results. I've now, every time I call this function, I have to use when result is success, when result is failure. And that's quite a bit of code that I have to write. Now, if you look at this example, it's like, oh, well, it's not that much. It's only like 4 lines of code. Right, but if you try and follow this pattern throughout your entire code base, it becomes quite cumbersome. It's a lot of code that you have to repeat over and over again for the sake of being more accurate and descriptive in how you describe your code. So this is where, for example, some things come in with arrow, which again you could do yourself, right? So instead of creating a result, what I could do is I could create a result of t, right? A generic type, and then pass in my actual result type in success, or I could do a result of t and r, and or success and failure, and then pass in the different types for success and failure. You following me? And then that would basically create a generic type, and then use that over and over again, right? But I would still need to declare all of these classes, etc. So now what Arrow allows you to do is take the same concept and use some of the data types that Arrow provides. And one of these data types is called either, or depending where you're from, either. And you call that either, and then either takes 2 types. It takes the left and, you guessed it, the right. The right, there you go. So here you can say I take a string, and in this case I'm going to take a string, because in both cases I'm going to return a string. One is with the contents, one is with the error message. And then I say either left, and then either right. Okay? So all either is basically a data type defined in arrow that essentially just says my type can return either a left value or a right value. That's it. That's all it is. And then here what I could do is say, well, when A is either left or right, and when either is either left, do that, right? And then this one is called A for the type, the property is called A, and in the other case it's called B. Okay, sorry, A, and oh, I called that. Oh, sorry, C. So right would be B, or C dot B and C dot A. Okay, I should name things better. Yeah, this is arrow. This is me. Okay, so I can rename this result, right? So that's good in that, okay, it's cut down the amount of boilerplate code that I have to write for the data classes. So now I no longer have to provide those data classes. Especially if my data class is essentially a single property with a property string, I no longer have to do that. If it was an int, I could return an int. I could return here either 4 or 4, for instance, right? It doesn't matter. I can return any kind of type I want. However, this still exists, right? I still have to do that when, etc. Now, when we were talking about for each, and when we were talking about map, and when we were talking about all of these functions, what were we doing? We were essentially abstracting that functionality away into a higher order function and passing in a lambda. Could I do the same thing? Yes, and that's in fact one of the benefits that this data type adds. Either adds the ability to cut down this boilerplate code. And what you do is you write result, fold, and fold takes 2 lambdas. Print line it, and the second one is print line it. Okay? That's it. So what fold does is say, take the result type, and if it's left, execute this function. So I call this left so that we see some distinction. And if it's right, call this function right and execute that. So what is now done is basically take away the conditional, abstract that away into a higher order function, which, oh look, all it is a when. Nothing magical, nothing mystical. All it is just a when. And all it's doing is just basically abstracting functionality into functions that we can use over and over again. So while you could create your generic type that I said about result and pass in the different types, what this is doing is adding more functionality to that generic type. So for instance, I have result fold. I can see if the result is right or is left, or do a whole bunch of other things, right? Map left, map right. Work with the actual results based on what it's returning. Okay? Any questions? Are you familiar with this? Okay. Now, the next one is option. Now, option you all know about. Option is basically, we've got an implementation of option in Kotlin native to the language, which is the null safe operator. Yeah? But option is a generic concept around null safe, which is essentially saying a value exists or a value does not exist. If you're doing Java programming, you're familiar with the concept of option, right? Or Scala. So here all I'm saying is that my function can return a string or it can return empty. Empty being a value that does not exist. In Kotlin, we have a specific implementation of that embedded in the language, which is the null operator. Okay? So every time you do question mark, dot, whatever, all that is saying is if it's not null, do something. If it is, then don't do anything. Now, people often ask me, like, when I introduce this concept of option to them, they're like, okay, so what should I use? Should I use option or should I use the null operator? Yeah? Well, it really depends. I mean, what are you trying to represent? Are you trying to represent the concept of null? Then there's no real reason to use the option unless you want to do any kind of chaining or anything that we've seen with the either. you can easily use the built-in support in the language. If you want to go beyond the concept of null, if you want to represent the concept of empty, if you want to do some kind of chaining and things like that, then absolutely you can use something like option. Okay? Now option allows me to do a bunch of things. So for instance, here I've got this function divide, which is now a total function, right? Because it's saying I am returning an option of int. So in all cases, it is going to work. So I say if y is greater than 0, then return x plus y. Just means a value. In the concept of option, option has either an empty or a value. That value is represented as just. You say just this value. But then again, notice when I'm using this, what am I doing? Again, I'm having to resort to the when, and again, I'm having to see if it is none, do something. If it is some, do something else. Some means that a value actually exists. So this is again where these data types that are provided in Arrow provide you with a bunch of helpers to make this less, smoother and less having to write boilerplate code. So here, for example, I have a function called square_it that returns an option. Here I have a function triple that takes an integer and returns an option. Now, if I were to do something like square_it where I take an option, how would I have to do that? Well, I'm taking an option, so I have to now distinguish from the time when the option actually has a value to the time that it doesn't have a value. If it is empty, I just do empty. Otherwise, I will do the value times the value. And if I want to start to combine these together, I have to again resort to all of these different conditionals. So what you can do is use a higher order function that does precisely that, right? Which is called map, which is an implementation of the concept of functor in functional programming, which is essentially taking one type and mapping it to a different type and knowing how to map that value that is being passed in. So here map understands the concept of option, and it knows that when I use map with a type option, I will decompose that in the scenario of when that option is empty and return empty, or when that option has a value, then perform the operation on that value. Cutting down again the amount of boilerplate code that you have to write. Okay? Take option further and start to combine values. So here I can say triple it option. So I'm passing in an option, and then I can take the result and I can map that. I can also do this thing called get or else. So get or else again is a function that is associated to option, which essentially says if there is a value, get it, otherwise perform some action, right? So that action could be print out a value, that action could be provide a default value, it could be a whole bunch of different things. But again, this is built into the type, so you can access it without having to write any code on your own. Now if we take this concept of option and or even either the example of divide, what happens if we want to, for example, have our code throw an exception, right? How do we make this code here, which is the divide, or I had it somewhere, wherever, I had some divide, how can we make this a total function that is explicitly saying that this can throw an exception? How? We use Java and checked exceptions. No. Sorry, that was supposed to be a funny joke. But my mother always said, if you have to explain a joke, it's just not funny anymore. Actually, my mother never said that, but anyway. So here what I'm doing is I'm returning a try. And try essentially encapsulates the concept of an exception. So I say that here I'm returning a string, or I'm throwing an exception. But I'm actually not throwing an exception. What I'm doing is I'm wrapping that exception in a type and then returning the type of that exception. So this is also useful if you have legacy code that is throwing exceptions and you don't want to have that exception in your work, in the code flow. What you can do is wrap that in a try. And then that try now becomes a data type that you can operate on. So here I'm getting a get page with throw that throws an exception, but what I'm doing is I'm just calling get page with throw, and here again I can do a get, or I can do an exist, or I can do a map, or whatever. And if it fails, it will just return to me the type of the exception that has been thrown. It is not going to actually cause a break in the flow, and it is not going to throw that exception. Okay? So these are a bunch of classes that you can start to incorporate in your code base, which essentially allows you to cut down the amount of code that you're writing over and over again, and potentially make your code a little bit more descriptive. And then you can go one step further and do specializations of certain types of data types. So validated is the concept of I have scenarios where I need to validate some input, and that method, what it is doing is validating that input. So, and if it's valid, it will return the actual result. If it is not valid, it will return an error. So you can return a specialization of either, which is called validated. And then that can be passed back when some, I don't know, validation error occurs, etc. Okay? So again, here you can see that in all cases, I'm basically using simple constructs of fold, map, exist, etc. throughout all of these. Okay? Any questions? Nothing? Okay. So, now, how many are familiar with higher kinded types? Okay. So, I'll show you this and it'll scare you away, and this is like the scary stuff in a way. This is also a concept that exists in Arrow, yet it's, how should I say this? So one of the questions that people often ask is like, oh, why don't you include some of the Arrow stuff in the standard library? Because, you know, one of the things that we try to do with Kotlin is not become Scala. And I'm not saying that Arrow makes it Scala, but definitely Arrow is something that not the general audience that's coming from Java or from C# or some of these things are adopting, right? In any case, also we want to keep the standard library very small. Now, one concept that is used quite often in functional programming is the is the concept of a higher kinded type, which is essentially kind of like a generic of a generic. And the idea behind a higher kinded type is that, you know how when you create a generic type, you're essentially creating a single implementation that could be instantiated for different types. So imagine if you, for instance, you're writing some code that, how many of you are Android developers? Yeah, there you go. Right, majority. So a lot of you might have used RX, right? Have you used RX? Right? Now imagine that you're using, imagine that you've written some code for RX. And now coroutines come out and you're like, oh my God, I got to switch over to coroutines. And we're like, no, you really don't have to. You're like, no, I really do because it's really cool. And you're like, no, really, you don't have to. No, yeah, you will. And so you switch over to coroutines, and what do you do? Well, you rip out all your code, and everywhere you're using RX, you replace that with coroutines. Imagine if you didn't have to do that. Imagine if you can basically instantiate that coroutine at the last possible minute where you are firing up your IOC container. That is the idea behind higher kinded types. It's like raising the level abstraction one level more so that you actually don't have to even program to specific types, that you can replace those types at runtime. So to put it in layman's terms, you can kind of think of it as a generic of a generic. Now, Kotlin doesn't have native support for higher kinded types. It's something that Breslov was talking about adding at some point. And what Arrow does is work around this with a whole bunch of ugly syntax and a whole bunch of annotations, etc. But this is essentially how you would basically represent a higher kinded type. You have this the kind of f of list of something, right? So this could be an observable, it could be whatever that would be instantiated at the last possible minute. Sorry, the f. And then kind is essentially, if you navigate to kind, it's a bunch of interfaces, and like, yeah, and then you have to write these concept of applicatives and stuff like that. Well, I'm not going to get into that, but point being is that if you want to take it another step with Arrow, it also provides this kind of functionality. Okay? Now, some other things that you can again do without having to, you don't even have to use arrow here. You can write this code yourself. Let's take a look at some code here, right? So this is a few lambdas, and the first lambda basically is taking a function and is returning data prefix to the parameter name. The second one is taking a path and it is reading all the lines in that file. And the third one is doing a regular expression, right? So if I say to you, hey, I want you to create a function that finds all of the regular expressions, a pattern inside a file, how would you do that? Well, you could write a function that does file name source, gets the result of that, does contents all lines, get the result of that, finds matches, and then returns the result of that, right? But you're actually defining a function here. But you've got all of these little primitive building blocks. And is it necessary that every time that I want to combine these, I have to create a new function and pass in values and operate on values, etc.? Or is there another way that I can compose these? Essentially, what I'm saying is that if we consider function as primitive building blocks, it would make sense for us to be able to compose these functions, right? So in maths, or in normal whatever, you have a function that takes an x and returns a y, right? And then you have another function, g, that takes a y and returns a z. Now you know that you can always do f of g of x that returns a z, right? Because as long as the input type of this function is the same as the output type of the other one, you could essentially compose these functions. Could you do this in programming? Absolutely. And this is where you can use something like compose, right? Now compose, what is compose? Can anyone tell me? I'll give you a hint. It's a function. But what type of function is it? Infix function, right? So compose is actually an infix function, and what it's saying is that I'm going to create a new function called composed function that takes find matches, composes that with all lines, and then composes that with source, right? And there's an alternative of that, there's a flip side of that, which is forward compose. But compose is essentially an infix option, an infix function. And you can see that, you know, it's nothing very complex. It's basically a function that takes two functions, composes them, and returns the result of applying one function to the other function. And this allows me to create a new function now, which is called composed func. And then I can use this composed func wherever I want. Okay? Now, there's also the idea of, let's say that I have some code like this. Let's say I have a function, first process that returns a list of string, and then a second process that returns an integer. And what I want to do is I want to take the input of one and put it to the output of the other one. Right? Now, in Kotlin, you could do this all the time, because if I say, for instance, you know, val n equals 1 to 100, n, look at everything I've got. I've got filter on that. And then on top of the filter, I got map, right? And on top of the map, I've got last index. I've got all of these different wonderful things. How do I get all of these wonderful things? Well, these are all extension functions on a collection. Therefore, it allows me to basically take the output of one value, push that into the input of the other value, and return the ultimate result. But what if I want to generalize this without having the possibility of creating extension functions? Because there is no extension functions on list of string, which is called second process. How would I do that? Well, of course, I could define an extension function, but do I really want to do that? Or maybe use something like pipe. And what pipe basically does is essentially take the same thing that you do in here. I mean, you've all used this thing over here, right? You know, ls, pipe, whatever, grep, yes? That's exactly what pipe does. It essentially takes the output of one function and pipes it into another function, right? And if you look at the definition of pipe, there it is. Now, this goes up until 22 parameters, and you know, as I say, like, if you hit 23, not having a pipe with 23 is not your problem. Okay? You shouldn't be hitting anywhere beyond this. Okay? Like that's borderline. Like this is like, no way. This is like, oh my God, they're going to remortgage my house kind of thing, right? So I don't know why they would remortgage your house if you got 4 parameters, but it's like a critical thing in your life, right? So pipe also exists here as well, right? And again, this is defined in Arrow as a single module, but you can see that you don't need to even do that. You can just do copy paste and there you have it. You don't even need Arrow. And since they don't even have a license, so who cares? It's not GPL, which is what's important. I'm not saying GPL is important. I'm saying it's never mind. Now, currying is another concept that is around functional programming that you don't really often use directly, but it's good to explain currying when explaining partially applied functions. So who's familiar with currying? So currying comes from Haskell curry. And the idea is that in Haskell, in the language, every function is curried. And what does that mean? That means that any function in Haskell that has more than one parameter isn't actually a function with more than one parameter. Every function with multiple parameters in Haskell is decomposed into smaller functions of single parameters. That's what currying means. So here, if I have a function called sum that takes 2 parameters, what currying does is essentially decompose that into single parameter functions. So now I'm going to get a function called sum curried that's got a single parameter on which I can then call with the second parameter. Now, why would you care about this? You wouldn't, other than say, hey, I know what currying means now, right? But there are scenarios in which this idea, I mean, in Haskell, because of currying, it allows many, many things. So in one of these things that you can do is partially apply a function. And this is kind of useful. So what partially does is essentially take a function and set a specific parameter value and give you back a new function with that first parameter set. So if you're familiar with Kotlin, you know that you could do fun inc by x, and then x equals 0, and then x plus 1, whatever. This is a default parameter. So every time I call inc by x, if I don't pass in a parameter, it's going to apply 0. But the only thing I can do with this is call it and get a result. But imagine if you could define this int equals 0 at runtime, so to speak, right? So that is what partially is. What partially allows me to do is set a specific parameter at runtime and then reduce the number of parameters on that specific function. So take sum partially 2. What that is doing is saying the first parameter I'm going to apply the value to. And what this is going to give me back is a function with a single parameter. So if you run this, by the way, that's also, if you don't know about that, install that. Do you use that or not? Yeah. This is very, very good. It's called the Neon Cat Progress Bar. And the good thing about it is essentially that every time, sometimes IntelliJ does go slow. So with this one, you don't get pissed off. You're like, oh, look at the cool cat. And you don't bug us about it. So you can see that what I have here is a function that takes a single parameter and returns a result. So I've gone from sum, which was 2 parameters, to sum partial, which is only 1 parameter. And then when I call sum partial with 3, it's going to return 5. Now, why is this useful? Well, if you're familiar with, to give you the quintessential example that they always give. If you're familiar with objects and classes, you're probably also familiar with the concept of dependency injection, right? Yes? So with dependency injection is where I have a class and essentially I can have constructor injection where I'm passing in a dependency from another class and then I instantiate that with using dagger or coin or whatever you want at runtime. Now, if I have functions, let's assume for the sake of argument, like in Kotlin, I don't have to define classes. So if I'm passing in, if I don't have function, if I don't have classes, how can I pass in other functionality to a function, right? How can I pass another class that I could potentially modify at runtime? I can't. Essentially, I pass in behavior in the form of a function. Now, let's say I define a function that's called repo, like repo, and then repo is always going to go to a database, right? And it's going to implement some functionality that goes and reads from a SQL database. Now, if every time I want to read from a SQL database, I have to pass in that functionality, this becomes painful. But why would I want to do that? Well, because, for example, for tests, I don't want to read from a SQL database. I want to read from a mock object or just return a fixed amount of objects. So this is where partially applied functions come in handy, because I could define this generic format of the function and then define a specific one that I'm actually using in my code that is setting a single function, a specific behavior every time I call repo. And then in my tests, I could have a different version which is actually passing in the function. That's where the idea of basically setting partially applied functions comes in useful, right? Because you know, if you think about classes as basically containers of behaviors, which is unfortunately a lot of times what we use, this is the way that you pass behavior to another function inside your class. You're essentially passing in behavior. So you could do the same thing with higher order functions. Okay? Any questions here? You got to give me a break. I mean, ask me a single question here so I can like breathe a little bit, but no, okay. Right. Now, there's a whole bunch of other things that are available. I'm going to stop at this in terms of the data types, etc. Notice that I haven't mentioned monads. I'm not going to. How many of you are familiar with the concept of a monad? Okay. So the great thing about, like, you know, they say that there's this myth that once you fully understand what a monad is, you can never explain it to other people. And it is true. There's like 1,000 tutorials online about monads. They've compared monads to burritos, to cats, to dogs, to cats inside burritos, and it's extremely difficult to explain at times. But if you can't understand the concept of all of these options, etc., imagine a scenario in which, you know, here I have functions that are passing in a specific type of option and returning another option, and map, for instance, knows how to work with that type. Now imagine a scenario where I could have these generic types and every function knows how to interoperate with that type, introspect the value, operate on that value, etc. That's the idea where I can bring in this concept of monads, where essentially I can have interdependent operations doing different things, and then, independent, these are independent, but at the end I'm going to use the results, right? So here in this code, and I'll try and explain. Now, monad, etc. here is a little bit very explicit how you write a monad in Kotlin. This syntax has slightly changed. In a language like Haskell, a monad is essentially represented as a vertical bar. But here what I'm doing is I'm calling try, and I'm saying 2 to int, 3 to int, and 5 to int, and then I'm printing the result, right? So if I run this, it's going to return, if I run this, not the other one, it's going to return 10, okay? Now what happens if I write a here and run this? It's going to not return anything, right? Because what it's doing is basically short-circuiting out of this, right? It's saying, okay, this basically has thrown an exception, and I'm going to short-circuit out, and I'm not going to return a value, right? But here I'm printing the value, but the benefit of this is I can also, again, chain it. I can do get or else, etc., right? So the idea here is essentially where you have types, and you can basically communicate. You have functions that allow you to that return different types, and then each of these functions, as you're combining them, know how to introspect the value that is coming in, operate on that, and then wrap that in a new value and pass it down the line. It's kind of a way of pipelining. Okay? Now, I want to touch on a few things that The right screen didn't like monads. I want to touch on a few things that often are raised when we're talking about all of these things in terms of functional programming, which is the idea of performance. Do you need me to do something or not? No, you're good? Okay. So, how many of you are familiar with the concept of inlining in Kotlin? Right? So, inlining in Kotlin, basically, if I have a function called sum x int y, x plus y, and if I write inline, what that's going to do is basically copy paste the code. So every time I call sum, it's actually going to copy and paste the code. So it's going to save on the actual call stack, right? Now when you write inline, you see that you get this little hint over here, because essentially in Kotlin you do not need to inline functions that are just normal functions and not higher order functions, because the performance impact isn't that great. And the JVM does better inlining than Kotlin would. So Kotlin gives you a hint and says, expected performance impact of this is insignificant, you shouldn't inline. Where it does make sense to inline is when you have a higher order function. So if I have a higher order function here, now you see that the warning disappears. Because inlining, what it is doing is not only inlining this call, it is inlining the higher order function as well. Right? So it's basically doing copy paste of the entire code. If you look at the standard library, like did I have the standard library open here? I did not. Did I? I did not. Okay, let me just val a equal 1. Filter. If you look at any function in the standard library, the majority of them are inlined. Okay? Now, there's another construct which is called no inline. Can anybody tell me what that does? Anyone? So if inlines, no inline would?
Prevent the compiler from inlining.
There you go. So why would I use, you don't use no inline here really. Where you would use no inline is in an inline function, and if you have two lambdas, for instance, that you don't want, one of them you don't want inline. So if I have this G over here, what I could do is say no inline, and then that one won't be inlined. Now, why would I not want to inline a lambda? Well, amongst other things, is that if I have an inline function, and if I do z equals f, that doesn't work. It won't allow me to reference that function. Why? Because it's inline. There is no object. It cannot represent it. If I want to be able to reference that, if I want to be able to store that function, then that function needs to be no inline. Okay? There's also another one which is called cross inline. Anyone knows what that means?
If this function will return something, it will not break the segments.
Yeah, which is kind of like this. To kind of understand this also is let's take a step back a second, and let's take a look at, for example, print something. I'll write a function which is called print something, and what this is going to do is it has a list of values, and it says L for each if L is divisible by 5, L if it is divisible by 5, then return, right? Print line something. Now, if I call that, what do you think that will do? How many times will it print something? 5. I hear 5. Do I hear 20? 0. Why 0?
Print line is out of the for each.
Print line is out of the for each. Okay, but why? Like, if you know Kotlin, you know let's just check to see if you're right. It prints 10. It prints nothing. Why though? Like, okay, I know that the print line is out of the for each, but why? Why is this behaving like this?
Because for each is inline.
Exactly, right? Because for each is inline. So when I do a return on an inline function, it is returning outside of that, right? If I want to return at the actual, if I want to do a local return, this is called a non-local return. If I want to do a local return, I would have to do a return at for each, right? Or explicitly use a label. Or I could use an anonymous function, which in Kotlin is different to a lambda, right? In all other languages, a lambda is the same as an anonymous function. In Kotlin, it is not. It is different. Now, the idea of cross-inline is that these functions don't allow non-local returns, right? That's what the idea of cross-inline is in comparison to inline and no-inline. Okay? So, inlining in itself allows you to what? To basically cut down on the call stack, make things a little bit more efficient, and if you're using higher order functions, you're not going to have that penalty of so many call stacks when you're using inlining. But there are other issues when we're using functions as primitive building blocks. One of them, for instance, is recursion, right? So here is Fibonacci recursive. Now, if you look at that, it is very, very simple to understand. Everybody understands Fibonacci, right? Because it's returning the Fibonacci recursive of n-1 plus n-2. This one is not so easy to understand, right? If I call this Joe, you won't know what that is unless you've actually memorized the Fibonacci in iterative format. You won't know what that is. But why is this? Because again, we're doing kind of like abstracting higher order functions, so it becomes easier to understand. Now, what happens if I run Fibonacci of recursive of 10? So let's run this. 55, 20, 50, and I'll just sit here. Like essentially I will wait here and I will probably go get a coffee, come back, have a shower, and this still hasn't finished. Okay? Because once you hit a certain number, this becomes really, really bad in terms of performance. And one of the reasons is why? Because it's basically computing the same value over and over again multiple times. So, however, if I do Fibonacci iterative of 50, that works immediately, right? And if I do 500, that works immediately as well. Okay? Now, how can I leverage this? So one of the ideas behind functional programming is also, which I haven't talked about much, is the idea of eliminating state, is eliminating moving parts. And if you look at that, what I'm doing is in my head, I have all of these moving parts and I have variables that are mutable, which means that I have to reason about these things. So one of the ideas behind functional programming is, again, to remove these moving parts, and that any function always is pure, right? And pure means that that function, whether you call it once or a million times, it will always do the same thing, it will always have the same result, and it will not have any side effects. So if you call a function that's altering some global object, that is not a pure function. So the idea behind a pure function is that imagine that if you actually take that function and you replace it with a lookup table, the behavior of the program will not change. It will be exactly the same. Now, if we have the premise that our functions are pure, that means that if I call it a million times with the same input value, it'll always give me the same output value. Well, what if I convert those values into tables, into a lookup table? And that's what the concept of memoization is. And for example, in language such as Haskell, functions are actually memoized. So every time it's called with specific parameter, it's not going to recompute that function. In Kotlin, you don't have that. But what you can do is create a memoization. Now, this is a layman's implementation, naive implementation, because other things are, this function isn't actually pure because I'm altering a global state. But again, you could do this in a nicer way to wrap it, and in fact, Arrow has an ability to memorize functions, kind of like the property delegation of lazy, doing something similar there. So with Fibonacci memoized, let's try and do that same calculation, right? If I run this iterative, you see how fast it was, and if I run Fibonacci memoized and run the same code, you see how fast it was. It's essentially the same thing. What's the difference? That Fibonacci recursive is way easier to reason about, way easier to understand, because recursion is actually a very nice tool to reason and understand code, right? Because it's using the concept of divide and conquer. And we can solve the problem that is associated with recursion, which is generally a penalty performance, by using techniques such as memoization. Okay? And one other thing that is also available in Kotlin is the concept of tail call optimization. So here I have a function factorial that again is very simple to reason about. The problem is that again, factorial could be more performant. And any function that is tail call recursive, which means that the last call to the function is the function itself, can go through what's called a tail call optimization, which is basically the compiler is going to replace it with a loop. Now, factorial isn't tail recursive, right? Why? Because the last operation is what? The multiplication. It is not the function itself. But if I were to convert this into a tail call, which is a tail call, which is a factorial, which is a tail recursive, which basically is passing in an accumulator, right? The same concept as fold does. Fold passes in an accumulator. What I can do is tell Kotlin to make this function tail recursive. And then what it will do is replace that with a loop. Okay? So these are just some techniques that you can use to kind of improve in terms of performance some issues that you may give rise to if you're using functional programming. And again, like a lot of times this is very like micro optimizations at times, because yeah, I mean obviously Fibonacci, if your code is doing things like Fibonacci, yeah, then it's going to have a major performance impact. But a lot of times, you know, our code optimization should lie in things like our database calls or our HTTP requests, and not actually our call stacks. Okay, and with that, it is now 7:30, so I think we're done. Any questions? 0. You know, I thought that you know, when I retire, I'm going to write a book, and the book is going to be called Audiences Worldwide, and it's going to like categorize the different types of audiences. Those that are like you have to check their pulse to see if they're still alive. Those that just sit there silently. Those that give you this look like, what the hell are you talking about? Anyway, so no questions.
Personally, the arrow.
Arrow, yes. Yeah.
Don't you think it's a bit too cryptic? You use left to right instead of failure success. Doesn't it make it less readable?
That is a fair point. So, you know, the question is left and right less readable than success or failure? I guess the trade-off there, that if you understand what left is and what right is, then it's worth the trade-off, right? Because it's exactly the same as like, won't you ever use fold because you don't know what, fold is not more explicit than using the function that implements fold, or filter, right? I mean, the first time that I was encountered with filter, I didn't know exactly what filter does, right? And especially it was in C#, which in C# it was called, I think it was called when, where, right? Because they didn't want to scare C# developers, so they introduced it as database. Yeah, it was called select, where, and whatever else it was. So yeah, that is a fair question. Is either, I generally don't find it less readable. Like immediately now when I look at either, I know that it's a type that returns one of two values. Sure, you can return a tuple as well, right? Or a pair. But, here it's, again, the data type and the functionality, additional functionality that provides you, right? Like the fold and all of those member functions. But I don't use everything in Arrow, far from it. So I use, right now, I use pipe, I use composer types, I use some of the data types. I'm not using any of the monads yet, because I find that there it's a little bit too cumbersome still. And I'm definitely not using higher kind of types. And I have seen code with higher kind of types, and it is not pretty. Okay, especially when you have to write all of this. Right. Any other questions?
Do you have some more complicated examples of like with arrow? I mean, you showed us like some simple functions, but if you have some, I don't know, application where you use arrow.
Well, yeah, but the application that I'm using arrow is basically using eithers, options, and the data types that I've shown you. I mean, there's not much complication to it. The code that I've seen that would be complicated is that code, right? That code, which is using the higher kind of types, right now it reads very, very complicated. Yeah. If you want, look through the examples or the tests of arrow to see some samples. But really, like, I don't think that nothing is really complicated. I mean, even that isn't complicated. That is hard to read. That is hard to grasp in your head. But nothing is complicated. It's all more about not familiar, right? You're not familiar with either. You're not familiar with validated. Once you're familiar with that concept, then it's not complicated, right? It's exactly the same as, option when it came out. The exact same thing as for each. Right? Okay, for each is a little bit descriptive but it's not more descriptive than either. Right? A return type either, you know that it's either A or B. Right? Yeah, either dot A and B is not that nice. Right? And because that's one of the things that we tried to move away from. One of the reasons that we actually got rid of tuples in Kotlin was because once you go over a pair or triple, it becomes cumbersome to understand what value represents what, because you can't have named tuples in Kotlin. So that's why we favor data classes. But yes, definitely, a lot of the reaction is, oh yeah, but either isn't as pretty as my data classes. It is not. But when you start to follow that concept of, okay, my functions are going to return data classes and they're going to be sealed, and once you do that 4 times, you're like, okay, this is starting to become painful, right? We could solve that. We could write IntelliJ templates for it. That was a joke. Any other questions?
So homepage is empty and there is a documentation.
Huh?
So you showed us this is empty page. So
Yeah, because I don't have an internet. Do I have an internet connection?
Because you are in Prague, yes, okay.
Yeah.
That's why Václav, yes.
Yeah, I don't have an Do I have?
Just
Iman?
Yeah.
And so I really had an actual really bad thing happen to me recently. I was in China, and so we had a JetBrains night, and we did the presentation in front of, I think it was 400 people or something like that. And I finished my presentation, and I'm like, okay, if you want to learn more, go to kotlinlang.org, and kotlinlang.org didn't work, right? Which should, but normally, some things aren't accessible. And I on stage, I launched ExpressVPN, which then I later learned that VPNs are illegal in China. I'm not big deal. And then someone took a picture of that exact moment where it says connecting, and they shared it on Chinese social media, and it in 2 hours it had 50,000 shares, and people were commenting saying, "Oh, does ExpressVPN work? Great, I should try it." I'm I am not here to promote ExpressVPN. I came here to promote JetBrains. But anyway, no, that doesn't work anymore. So yeah, so you see, it's nice. You see, it's got even the wiggle. Documentation is okay. One of the things that I've also always given them feedback is sometimes you go to certain types of the documentation, like you go to, let's see if they've improved this, if you go to, applicative. So the applicative abstract, blah, 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 is maybe derived from monadic types that include a monad instance via flat map. And when you come to this, you're like, okay, what is a monadic type, and what is a flat map, and what is a type class? So they're improving that documentation a little bit. But generally there is type. Like what I use a lot of the data types, right? So either here gives you an example of either, try, validated. These are generally good. When you start to get into like things like sequence of K and stuff, this comes a little bit again cumbersome, but like use what you want at will. I mean, if I showed you the modules here, you can see that that's one good thing they've done, because that was one of the conditions of the merger between functional and arrow. Functional introduced a bunch of data types, composition, and partial functional application, and stayed there. Arrow brought a whole bunch of things. And the argument was, if we merge, let's try and make it so that people can use what they want without having to bring in everything. So really now it's basically very decomposed into modules. Any other questions?
The annotation processor for
The annotation processor is mainly for optics. So optics, you're familiar with optics?
I heard that.
Yeah. So optics is basically like, you know, what was that principle that you said you shouldn't do, like the Hollywood principle? No, it wasn't the Hollywood principle. It was like the dot, 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 dot. So you basically can drill in and set property values, etc., on immutable objects without having to reconstruct the entire hierarchy of those objects, right? Was it? What? I know. I'm saying, was it Liskov? No, Liskov was.
Substitution principle is that you should only talk to your immediate friend, not.
No.
Yes.
No. Liskov's substitution principle was that you shouldn't create a specialization of a subtype that is okay. It's not. You should never downcast something. For example, with Liskov, that's what Liskov substitution principle is. Liskov, rubber duck, Liskov. Functions that use pointers to base classes must be able to use objects of derived classes without knowing it. I think it's called the Hollywood principle or something like that. Anyway, you know what I mean, right? So that's what the optics does, okay? Because like one of the ideas here is that if I'm favoring immutable objects and I have to recreate those objects and I want to create a clone, while Kotlin allows me to just do clone or copy, I have to pass in the entire structure if I want to change one property. And what optics allows you to do is basically just set that one property, and it's just basically doing it through code generation, essentially, using the annotations.
But Hollywood principle, I think, is don't call us, we will call you.
Yeah. Also, every job interview I ever had. Yeah, well, you know what I mean. It's like the friends of my friends are not my friends. No, the enemies of my enemies are my friends. Yeah, but that's more kind of like, I was watching Narcos Mexico just recently. And that's why it's that.
It is law of Demeter.
Law of Demeter, that's it. There you go, the law of Demeter. Yeah, that's the right principle. Thank you. Okay, any other questions? I can throw in a little bit more around functions using in a different way with Kotlin creating DSLs. Are you interested in that or not? Yeah, okay. Okay. So I've shown you a whole bunch of stuff that you can do with functions. While this isn't classified as functional programming, but if you consider functional programming things you can do with functions as primitive building blocks, let's see some of the other things that Kotlin can do. So let's create a class. For instance, let me see what I've got here, if I've got everything already. Okay. Okay, let's do this. How many of you do web development? HTTP endpoints, Sinatra, Sinatra, Express.js, Ruby on Rails, Spring, sweet Jesus. Okay, let's assume I want to create a web server, an endpoint, a servlet, right? And I'm going to create a function called, for example, get, that takes a path, string, and then does something with it, right? So what it does, for example, is basically take a handler that takes, for example, a request object and a response object. So now I have class request val. What does a request have? For example, it has the content type, string, and it has the length, for instance, content length of type int. And then we have a class response that has var content string and status code of type int, right? So what I want to do is something like get home, and then basically here what I could do is request response, and then say, for instance, if request content type equals application JSON, then return, response content equals JSON, which I'll just, so I could say, like, bring in name, value, email, value. Okay? And then if not, else response status code equals 404, for instance, or no. What's the valid number for invalid unsupported media type status code? Huh? 405? I think so. It could be unsupported media type. Yes. Okay. Now this is nice. But one of the promises we made with Kotlin was that we can create like DSLs and nice little things with DSLs. And I also see a lot of noise here. I see request response as a lot of noise. Now what I could do is, what I would like to do is try and simplify this a little bit. Now you know that in Kotlin, if a lambda has a single parameter, you can refer to that parameter as it, right? So what I could do is abstract this into a class called handler, and then create a class called handler which has a val request of type request and val response of type response, right? And then this one I could basically refer to as x, and then, but I don't need to because it's a single parameter, so I could just replace this with it, and I could do the same thing with it and it, right? But this now belongs to request, and this now belongs to response, and this belongs to response, right? So I've gotten rid of the arrows, I've gotten rid of the request response, I've added it, but I now have to do it request, it response, it request, it response. What I would like to do is something a little bit nicer. So for example, if request, basically get rid of this it as well. So let's say, for example, if request content type equals application JSON, then response content type equals that, else response status code equals that. That's what I would like to do. Is that possible in Kotlin? Yes. Otherwise I want to be doing this demo, right? So how is that possible in Kotlin? Well, first of all, you can have an extension function, right? You're all familiar with extension function, right? Value string, this equals value, right? This is now an extension function to all strings. So this is a function. What if I pass an extension function? This is a higher order function, but I could pass in an extension function as opposed to a regular function. The syntax for that is very similar to here. I put in the type, the dot, and then the actual extension function. So that now gives me the request.content-type and response.content-type, right? So that's nice. I've got rid of the it. Now in the response content, I want to do something similar as well. I want to do something like that. Is that possible in Kotlin? Of course it is. Again, otherwise, shitty demo. So can I do that? Well, what am I doing here? Here I'm doing response, and then it feels like I'm passing in a lambda. So what I'm actually doing is I'm invoking an instance. Okay? So could I invoke an instance in Kotlin? Well, if I have, let's say, for example, I have a class called foo, right? Could I say val foo, and then do foo something? IntelliJ says no, and I say yes, right? That's the great thing about IntelliJ. You don't even need to know Kotlin. So what I've done basically is if you create an operator called invoke on any type, you can essentially invoke that type. So here what I'm doing is creating a type called foo, and then I'm calling foo something, basically allowing me to invoke that, right? I could do exactly the same here. I've got a response, which is what? An object. So if I go to response and say I want to create, well, let's go to the response over here, and say I want to create an operator, right? Fun, invoke, and then what is this operator going to take? Well, it's going to take a response, but it's going to take an extension function, response, and it's going to return a unit, right? And now I get my DSL there as well, right? Now this idea of DSL, you may have even used in Kotlin, this construct, right? Because you've probably used the concept of with, yes? Right? With is essentially that. If you take a look at with, it's essentially a higher order function that takes an extension function, which in Kotlin, this concept is called a lambda with receiver, right? This is a lambda with receiver over here. And all it's doing is basically using a lambda with receiver to allow you to write this type of code. Now, I've created a nice little DSL for my HTTP servlet application, but of course what you could do is, for example, create an application for configuration, right? And then do something like, configuration, Terraform, and then server, and then, for example, host equals 127.0.0.1, provider equals AWS, and essentially create a type-safe configuration, for instance, which is essentially a DSL. And trust me, you could do this. Like this is what I call DSL-driven design, right? Because I usually do it like this. I write what I want, and then I work my way back to try and define each of these different functions and properties and objects that I'm invoking, right? What this provides you is type safety. It provides more insight into what is available in each step for people that are using these types of configurations. And of course, if you combine this even with something like, this is this low-level configuration for Terraform, for instance, or for cloud providers. But if you do something like this, for example, around business logic, and you combine this with Kotlin scripting. Anyone use Kotlin scripting? So you know that Kotlin, you can do scripting as well, right? It exists. So you can write a Kotlin script and then dynamically load that script. Potentially, you can end up in a situation where you are defining business rules that can be defined in a script separate to your code. Okay? And those are basically just using a few options, few concepts. One of them is the ability to invoke objects. The other one is the conventions that we have around how lambdas, if they're the last parameters, you can exclude them from the brackets, and then multi-line lambdas, and a few things together allows you to create these nice DSLs, which is why we have things like Gradle, Kotlin, DSL, which I'm guessing that nobody uses yet, no? No. You do? Yeah? Any better? It's broken at the moment, yeah. Yeah. This is being recorded, right? Okay, that was that. So what else? Any questions? Okay, well then I guess I'm done. Thank you.
Okay, thank you, Hadi.
Thank you.